separate it into two integrals. That's what you want to do first. So you have the integral from 0 to 1 of x dx plus the integral from 0 to 1 of the square root of 1 minus x squared dx. You're treating it as the sum of two integrals. Absolutely. One of those is quite easy. Which one is easy? Left one or right one?
Left one.
Yeah, you have x squared over 2 from 0 to 1, and that's going to be 1/2. There it is. That's a triangle, right?
So you can always
What?
part, like that.
Absolutely. Plus and minus. Absolutely. Sure. The second one, though, what's the problem with the second one? You look at it and you think to yourself, man, that one looks like we might be able to use substitution. We just covered it. It looks like a radical, right? But what's the problem?
Won't cancel that one.
There's nothing to cancel with on the outside. If you let u equal 1 minus x squared, you get stuck real fast because you're going to end up with two variables floating in there. You really don't know what to do. I will tell you right now, you just can't integrate that with the calculus that you know right now.
Why don't we just take that quantity as being to the 1/2?
Okay, let's try it. Let's see what happens. So you want to rewrite it 0 to 1. It's the same thing, 1 minus x squared to the 1/2 dx. Okay, now what do you do?
Just do 2/3, that's 3/2.
Okay, let's try it and see what happens. That's absolutely something you could think to do, like this. So it's, what is it? 2/3 x to the what?
Yeah.
So if that is the proper antiderivative, the derivative of that should be the square root of 1 minus x squared, correct? It's not, though. This drops to the front, it cancels, but then the chain rule kicks out the 2x. If there was an x on the outside of this, could you use u substitution? Yes. It would work beautifully. Absolutely, it would work beautifully. But you don't have anything on the outside to cancel with. So that's where the second phrase comes into play. You get real sad at this point. It says, interpreting in terms of areas. So my question to you is, this means the area under the curve of that function. What does 1 minus x squared look like? It's a semicircle, right. This is, sorry, that's a bad set of axes. It's the upper or lower half of the circle. It's the upper, and it goes from -1, it goes up and down, and it goes to 1. So if you're interpreting this, and that's, again, poor distances, what are you trying to do? You're trying to find this area right here. That integral is that area right there. That's a circle of radius what? So the area is equal to pi times 1 squared all over what? 2, because it's half of a circle. Half of a circle. So what's the final answer? Well, it's 1/2 plus pi over 2. Done. What does the picture look like? That's what it's asking you when it says interpreting it in terms of areas. It's asking you specifically to do that because can you do that by hand? Not at this point. It's not easy to do that one at all. Basically, to do this by hand, you have to know, to a certain degree, where pi r squared comes from. Have you ever proved that before?
No.
No. It's not trivial. It's a little bit of work. Question, because you know this. X squared plus y squared equals 1 is the equation for a circle of radius 1 about the origin, right? Y squared is equal to 1 minus x squared, so y is equal to plus or minus the square root of 1 minus x squared, right? The negative is the one below. Why do you have to have 2? Because a circle, is that a function? Because it doesn't pass the vertical line test. So how do you make it pass the vertical line test? Break it into 2 pieces. Break it into 2 pieces. Exactly. Good. You will hit math, and then it's math 9. Function int, and then you do vars. You have to do y vars right here. And I'm pretty sure you have to do comma. You have to tell it x at one point, and then comma the lower bound, and then the upper bound. I think that's the order. I always forget. You hit enter, and there it is. So it's doing the same exact thing that we just did. It's doing the same exact thing. What method are we going to use? U substitution. U is going to be equal to what? 3 pi t, exactly. So what does du equal? 3 pi dt. So what does dt equal? Yeah, you got it. And now you just do the substitution. We're now in u land, so what did the limits of integration become? 0 to what? To 3 pi, because you're plugging in 0 and 1. And then you have sine of what? U times du over 3 pi. So you're actually evaluating 1 over 3 pi times the integral from 0 to 3 pi of sine of u du. What's the integral of sine? Negative, yeah. So we're going to have 1 over 3 pi times negative cosine of u from what to what? 0 to 3 pi. Can you factor out that negative sign? Is that okay?
Yeah.
Absolutely. So if you want to evaluate this, it's going to be negative 1 over 3 pi times cosine of 3 pi minus cosine of what? 0. We factored out the negative. That's why it stays negative like that. What's cosine of 0? You sure?
Yes.
Good answer. What about cosine of 3 pi? Negative. Cosine of pi, yeah. So it's -1, right? So what does that become? 2 over 3 pi. And you are done. What do you think u should be? Anybody want to guess? Yeah, that's a good one. I like u equaling pi t. So what does du equal? Yeah, pi dt. So dt is equal to u over pi. So this is just going to be the integral from what to what? 0 to pi of e to the what? Times e over pi. Exactly, you got it. So this is just 1 over pi integral from 0 to pi of e to the du.
Every time I don't use u substitution, I forget the.
So that, yeah, so please just do it. You think it's easy, but then you're going to forget the easy piece. When you plug this in and cancel, what do you end up with? 0. What do you end up with from your limits here, though? What does it become? Tangent of 0 is? 0, but then you add 1. It's 1 to what? What's tangent of pi over 4? 1, so it's going to be to 2 of u to the what power? U cubed, exactly. And you're going to have a du over secant squared that's going to cancel, so you're left with du. Yeah. Is that kind of nice? We're going to stop there. You can finish
Why
it.
do you have to do the changing into tangent? I guess.
Why? Because look, we are now in u values. These are x values. These are t values. We're now going to u values.
Oh, and since u is 1 plus.
U is 1 plus tangent. You plug in 0, you get 1 plus 0 is 1.
Right.
Tangent of pi over 4 is 1. 1 plus 1 is 2.
But
gotta remember to do
but
that.
you're gonna change u into 1 plus tangent t.
No, you don't have to. You've already once you're in for definite integrals, you don't need to translate back. You've already changed if you've changed the limits of integration on a definite integral, your value, and you don't need to change back. That's the whole point. It really, really helps. You could go to the end, resubstitute, and then plug in 0 to pi over 4, but you're doing the same math. By hand, shall we? Let's do the first one. So the first one for 56 is going to be the integral from 0 to 5 of, what was the equation? T squared minus t dt. And that's going to be 1/3 t cubed minus 1/2 t squared from 0 to 5. What's nice about 0? 0. So you end up with 125 over 3 minus 25 over 2. So you need to turn it into sixths. So you get 250 minus 75 all over 6. So it's indeed, what is it? Yeah, 175 over 6. So that verified. So we compute this, it thinks about it, and you end up with a decimal probably. What is that? What can you assume? Oh, it's not coming up there. Interesting. There it is. Great. So what do you think that answer is? Hold on. You can do math and then math and fraction, but the problem is you're not going to get the proper answer if you do that. Why? Well, there's a problem here. Like this is an estimate only, right? When a calculator does these, is it actually doing calculus? No, it's not doing calculus.